Nick Schrock is the founder of Elementl. And prior to Elementl, which is a company behind the popular open source project Dagster, Nick was a principal engineer and director at Facebook from 2009 to 2017, where he founded the product infrastructure team and co-created GraphQL, another very popular open source project. Welcome, Nick.
Thanks for having me.
Very good. So I'd love to start with a discussion of the current state of the data ecosystem, basically the premise for the creation of Dagster and then Elementl. What was the problems that you saw that you wanted to address?
Yeah, that's a great question. It really is a fundamental thing. So if you go to, for example, a conference about machine learning or data science, you often hear people say that I spend 90% of my time data cleaning and 10% of my time doing my job. And that represents a fundamental problem in the entire ecosystem when people feel like they're not doing what they're supposed to be doing. And they might express that in terms of that pain, but it's actually a more, often a more complex issue than that. And the analogy that I had in my head was to front-end engineering, and then early 2010s. And what you would hear people say there is that I spend 90% of my time fighting the browser and 10% of my time doing my job. And for those of you who knew any web developers in 2010, you mentioned IE6, you might get an intensely emotional reaction in terms of browsers, for example. And that kind of stuff doesn't happen anymore, not just because IE6 doesn't exist. And it was really, the browsers had to get better, but it was really a holistic ecosystem problem. And it required tools like on many different dimensions. So like React on the front end, GraphQL played a part here, a technology called TypeScript out of Microsoft, tons and tons of tools had to get better. And you fast forward today and no one says that anymore. And so that was a core software abstraction and tooling problem. And I believe we're in a similar space in data today, where some people call it data ops, some people call it the modern data stack, but what really needs to happen in this data space is the software kind of engineeringification of data, the acknowledgement that this is not an outsourceable thing anymore, that this requires software engineering process specialized for the data domain and the tools and abstractions that match that. And when we've analyzed the space, we really honed in on orchestration and the encoding of these dependency graphs within data as a critical point of leverage on several dimensions. And so we think, transforming the orchestration space has a massive part to play in making the world better for all the practitioners that live within it.
And just to double click on that, I think you said, if you look at the evolution of the data space, that a lot of the sort of early wins in the data space over the last few years have really been around managing scale, and that we're now switching to a phase where the primary challenges are higher in the stack around productivity, testing, integration. Is that fair?
I think that's fair. You can think of it sort of like Maslow's hierarchy of needs. Mm-hmm. And when the amount of data started to explode, there was a very critical need that you couldn't even process it on a technical level. Like you could not scale out compute. And that's why, in the big data revolution, you called it big data. You started with, Hadoop and then Spark and now the cloud data warehouse. So now if you have petabytes of data, you are able to process that efficiently at scale. But now the problems are kind of higher up on Maslow's hierarchy, so to speak. So now it's, okay, we can actually process the data. Okay, what is it? Does it have high quality? Are the people that actually build the computations that process that data productive? Can you track that data throughout the ecosystem? And so on and so forth. So, an amazing engineering achievement happened in the throughout the 2010s, which was solving these massive, pure technical scale problems. But now we're talking about organizational scale, dealing with complexity, and dealing with developer productivity and any number of other dimensions.
So what's an orchestrator in the simplest, most sort of layman definition of the term?
Yes, the favorite question any engineer gets in terms of explaining what they do without confusing the hell out of everyone. The way I would explain it is that these data systems involve multiple types of people. So often you would have, say, a data engineer, an analytics engineer, and a data scientist. They use different tools. They have different skill sets. But in these systems, all data has to come from somewhere and go somewhere. So you can think, let's imagine a very simplified example. Those three people, they show up to a factory and one person's making one widget, they pass it off to the next person, then they pass it off to the next person. So before orchestrators, what would literally happen is that station one in the factory would take usually 2 hours to complete its task. And then the next person would start after that. But there's no way to actually manage those dependencies. So literally, it would say, okay, usually it passes in 2 hours. The first thing started at 1 a.m. I'm going to start every day at 4 a.m. So in the factory analogy, it's like putting a blindfold on someone and just saying, no matter what happens, at 4 a.m., grab whatever's up there and put it in your machine and hope and pray that it works. So that's a pre-orchestration world. So instead, the most primitive orchestrators, what they do, all it is person one does their job in their tool, the machine processes it, and then just taps the next person on the shoulder and says, what's going on? So at its basic level, if you think of the process like an assembly line, the orchestrator is kind of the factory around it that determines the order of things and makes sure that things happen at the right order at the right time.
Right.
Now,
yeah.
So that's a very basic definition of orchestrators, but they go far beyond that.
Yeah. No, and of course that leads into the question, like what's your take on an orchestrator? What kind of orchestrator are you guys building with Dagster?
Right. So I said that the one example where there's one assembly line and 3 stations. Well, that's not the way that ends up working. You end up having thousands of assembly lines, sometimes with thousands of stations, and they have all sorts of crazy interconnections. And then what's even more kind of interesting about it is that I describe the interactions between one person to the next. It happens both on a macro scale, meaning like they also interrelate teams, but also the individual practitioner will build their own little assembly line because it makes sense for them to do it. As they're figuring out what their data is, they might say like, oh, this is an intermediate data product that will be generally useful. And I kind of want to have like a checkpoint, right, in the process. So what ends up happening is that these systems explode in complexity, and you need to be able to take the assembly line offline, test it on test data, put it back. If something goes wrong, you need to halt the assembly line, maybe start it from a certain point, move it around. And then it also makes sense for this assembly line to be aware of and track the things that are actually coming out of it. So like, okay, I have this widget over here. It came from this previous intermediate, which came from this, et cetera. So we think this like orchestrator is really the central leverage point that makes sense to be the data platform. And also it's the place where people actually build their machines, sort of software programs, but continuing with the factory analogy, this is where they build their machines actually. And so it's critical not to just think of it as a operational tool, but as a place where people can productively do work.
Mm-hmm. Great. And so when did you start Dagster, and like tell us about the project?
Yeah, so I formed the company kind of in an exploratory sense in 2018, but we didn't really start working on it in earnest until late 2018, early 2019. And then we launched the project the summer of 2019 publicly. So I guess the question was kind of how did it start? I was looking around and exploring, taking an interest in this space and talking to lots of people. I talked a lot with Abe, and one of the next panelists, a lot in this time. And that's where we really honed in as orchestration as a critical part. And so I just started building, experimenting with stuff, building out in the open, getting feedback, working with people. And that was really the genesis of the project. And the genesis of the project was really the insight that, people think of data sets as physical things, right? Like a table in a database, right? But in the modern world, where you're really applying software engineering processes to data, all that data ends up being computed. And so what we thought really is that you should move the primary focus of energy from that produced data set to the process that produces it. Because maybe like you throw away that data set, you need to recompute it, right? Or reproduce it. It's really the computation which matters. That's the primary focus. We thought that you could really make, almost like the focus of the orchestrator, sort of this like virtual data set concept. And that was kind of the genesis of the project.
Mm-hmm. Which I'd love to continue down that path and maybe double click on how Dagster works, like some high level, easy concept. There was for example, a concept of a solid, which is your atomic units. Do you want to talk about that and how Dagster works in general?
Sure. So Dagster Works is an open source Python project. So, if you're a programmer, you can just type a simple command, pip install Dagster, and you're off to the races. You can write a little bit of code. And then, what you effectively do is you build these functions, we call them solids, which define like a computation, meaning like a step in the factory, to keep on that analogy. And then you can construct graphs out of that. And the moment that you use our APIs and structure your code in this way, you immediately have access to all sorts of tooling. So without any infrastructure on your laptop, you don't need to deploy anything. You can just type Dagit, which is the name of our graphical tool, and load it, and you get this beautiful rendering of like what this graph is prior to actually executing it. And then you can also use that tool as almost like a local IDE for these graphs. And then you effectively, one of the things that we really focus on at Dagster is being able to execute these computations, these programs in different environments. So you can like develop on your laptop and then also deploy it to a deployed, piece of infrastructure and not have to change the core business logic. And this is really something we focused on. And that's a critical piece of this. So, you develop locally, you have this fast local development loop, you can test things, then you can deploy it to any infrastructure. And then from that point, you're scheduling your computations. So you're saying like, I want to run this every day, or in a first class way, I don't want to run this whenever something upstream changes. And then you have all sorts of, what we consider consumer grade tools to monitor and observe those computations. So you can track both like, the process as it unfolds using a live like Gantt chart viewer, for example. And then we also track the assets that are produced by those. And we can backlink and say like, oh, this thing came from this computation, which is extremely useful when you're actually figuring out what's going on in these systems. So that's kind of, we take this through the entire process and thinking about like, okay, what's the fast developer and test lifecycle? There's a huge opportunity there for massive improvements. How do you deploy it reliably? Allow multiple teams to use common infrastructure. That's a critical thing. We think that Orchestrator is the center data platform. And then lastly, monitoring and observing those things, both the computations and the produced assets.
Great.
Assets being like a table, ML model, any physical materialization of something.
Great. Who's a good customer or type of user for Dagster? Like, do you need to have a a certain type of infrastructure in place? Do you need to be a certain size? Do you need to have like a specific type of talent on the team? Who's a good sort of like profile?
Yeah, so we've really found two classes of user who really gravitate towards the system. One is what we consider an emerging title of data platform engineer. A lot of people self-title that way. A lot of data engineers act as data platform engineers. But what they see is that, hey, inside every company, there's a data platform, whether they acknowledge it or not. And this data platform is where all these people come together, and all the different, like the data engineers can work with the data scientists, all this stuff can execute on time. You can have like one single management of all the important data and all the heterogeneous tools. And so that user, maybe they'll start out and they'll say, okay, all we need is like an ingest tool like Fivetran. We need something like DBT over the warehouse, and maybe a so-called reverse ETL or operational analytics tool to jam that back in. This is all kind of terminology laden and whatnot. But the moment they expand beyond that fairly prescribed, what's called the modern data stack, and need to do anything outside of that, they need an orchestrator. And they want an orchestrator that's kind of in line with the values of those tools. And a lot of those users have like really gravitated towards Dagster. Like one of our users said, like what DBT did for our SQL, Dagster did for our Python in very concrete ways. And and I would say the second type of user is that we really find starting to gravitate towards this are people building end-to-end model training pipelines. So they want to work in Python. They want to use tools like Pandas, scikit-learn. They want a fast development workflow. They want an orchestrator because they need it. And this tool really speaks to them. And often they have to roll their own infrastructure. And one of the things that Dagster does is really, we attempt to thoughtfully really think about the interface between what we call practitioners, those who are responsible for the production of data assets, and infrastructure folks. And those are kind of like two jobs. And sometimes one human is doing those two jobs. And the way to make that manageable is to have the nice software abstractions that deal with that. So I would say those are some of the primary use cases that come to mind.
Great, thanks. And help us understand how you position Dagster in the orchestrator segment. I mean, it's like all categories in the data world. There are other folks. We had Jeremiah from Prefect, for example, at a prior event. So there's Airflow, and then there's like all the historical ones, like Luigi. We had Kedro as well at the event. Like so for folks, what are the bright lines in terms of like thinking of Dagster in comparison to some of those other folks?
It's a great question, and as you know, positioning is always an evolving art. But I think the primary difference, and I'll focus on Airflow and Prefect since you started with those. And Airflow is definitely the dominant incumbent in the space as it's traditionally defined, is that they, in terms of they don't consider the full life cycle of developing data products. They view their mandate as very narrow and purely these operational use cases of ordering this comes after that, comes after that. And then there's operational complexity in that. So you need to know how to retry things and so on and so forth. But we think the graphs that the orchestrator encodes are one, complex enough that they need a full local development lifecycle that's fully thought out. And two are, in fact, in some ways, the structure of the applications themselves, especially the ones that are written in Python. And so we really think about the dev and test lifecycle. We also want to be data aware. And so that means that one, we have data dependencies that are encoded, meaning that, not only do we order the machines, but we know that upstream that, this input comes from this output. And without getting into details, this is what we believe is a much more natural programming model for practitioners. Dagster really also embraces the fact that these technologies are inherently multi-tenant, meaning that multiple teams want to be able to deploy to common shared infrastructure. And Airflow just wasn't designed like that. Kind of all the teams share a Python environment. These are all very technical things, but effectively one team can push up one mistake and bring down the entire system, which seems like a bad thing. And then, Airflow is not data aware. I guess I consider prefix lineage is very direct. Jeremiah was a primary contributor to Airflow, wanted to make some changes, wasn't able to do so, and went and started Prefect. And just like Airflow, Prefect views itself as a very strictly operational tool. So the framework is about positive and negative engineering, right? Which is like we take care of negative engineering, which is effectively like ordering those computations, retrying things, taking care of errors. Which is effectively new words to describe exactly what Airflow's goal is. And then they also describe their system as a insurance company. What's notable about that is that insurance companies don't make you more productive. I mean, I've never met an insurance company that makes you happier, for certain. And it doesn't really talk about the full end-to-end process. It plugs into an existing system and then, kind of deals with this operational complexity. And that's its only remit. We believe that orchestration is so central that you need to think of it in terms of a multi-lifecycle thing, and especially to think of it as a productivity tool.
Great, thank you. So what's next? You guys are a thriving startup. I know you did some integrations with DBT, with Great Expectations that we're going to speak with in a few minutes. What's next on the roadmap for the next year or so?
Yeah, so a year's a long time in a startup, and so you can never predict the future. We are I think we'll get to this but it is a venture-backed commercial company. So at some point we will need a revenue model, a business model. So I think it would be, without a spoiler alert, we are working on that aspect of the business, but I can't talk about that in too much detail. On the open source roadmap, I think there's two things. One is that, we've been what I'll call in sort of a open applied R&D phase of the company, where we've been really working with a set of targeted design partners and not hyper-focused on growing adoption and too quickly, because we didn't want to have too many partners because we knew the technology was still changing a bit. We're about to land, we're about to land some changes that will really set us up for kind of a pre 1.0 release. And we've learned a ton from the last, year and a half of work. And we really feel like we're settling on a set of abstractions and concepts which will serve the foundation of technology for years and years to come. So in the short term, that is really our focus. And I think beyond that, once we have that stable core that we feel can be the foundation for years to come, we will focus on pushing up the stack and really focusing on things like, for example, improving our asset catalog and making that super rich, and taking advantage of the things where we can uniquely do things that vertically integrate our asset tracking with the orchestration layer. We also want to focus on expanding the set of stakeholders who can interact with the system, because we've seen a lot of early users do this really effectively, where non-technical ops folks are able to self-serve workflows without any intervention from the data platform teams, which is just incredibly valuable. And we expect to double down on things like that. So that's kind of what we're thinking in very broad terms.
Okay. Very good. Okay, well, as we are getting close to the end of the allocated time, why don't we finish with a couple of sort of like rapid fire questions, which have nothing to do with Dagster. So first question, outside of Dagster, what is something in the data ecosystem, whether that's a tool or a project or a company you just love and you just think is the coolest thing?
Well, obviously it's Superconductive and Great Expectations and Maraxa, because they're the best tools ever. And if I hadn't founded Elementl. I'd worked for one of them. Hi, Abe and Tavares. Present company excluded. I think I'll give probably a common answer, which is, DBT is really taking over a big part of the stack. And I've known that team since 2018 when they gave a conference talk, and I ran up to them because I was super excited what they were saying, because I felt like we shared a lot of alignment on values in terms of the way you can structure these things. You have data dependencies, all this stuff, but they were very specialized for SQL. And what's really cool is I think they're really on the forefront of saying, hey, the way to do this is not to try to remove analysts from the equation. The way to do this is to bring engineering processes into their life and, so-called upskill them. And that not only makes them more productive, it actually allows them to retitle themselves, be sufficiently different where they actually make more money. They associate their career with technology. And I really admire technologies like that. I feel like kind of previous work in front end is like that, where GraphQL and the kind of the sibling team React, that shows up on people's resumes, and they really invest in that in their careers. So I really like technologies like that, that
Very cool.
kind of aren't just more efficient, but help with careers. And then actually, I've been really impressed with the development of Spark over the last few years.
You can say one.
Oh, okay. There we go.
And last question, 1 minute or less. How does somebody like you learn? What are some of the data, learning resources you'd recommend, whether that's a newsletter or podcast or conference, just whatever comes to mind, one or two, but just quick one.
Podcast. Totally
okay.
Podcast.
Which one do you like?
I really like Software Engineering Daily and Data Engineering Podcast. And then the other thing is that you shouldn't fear to reach out to someone who's on one of these podcasts. Just email them and be, hey, I thought what you said was super interesting. As someone who's on podcasts, if I ever get that email, I'm super excited to talk to the person. So both podcasts and direct
flattery will open doors.
I call it, just interest, I would say, rather than flattery.
Okay, wonderful. Look, this was great, super interesting. This the popularity of Dagster and the number of times it comes into conversation is really impressive, considering that ultimately you guys haven't been doing this for a very long time. So congratulations on everything you've built, and excited to see how you progress over the next few months and years. And hope you come back at some point soon and tell us about all the great things you've achieved.
Awesome. Yeah, thanks. I hope to live up to your expectations.
All right. Thanks, Nick. Appreciate it.